For over a century, one math problem has haunted the world's greatest minds: the Navier-Stokes equations, a million-dollar mystery no one could solve. Until now. DeepMind's AI just did what humans couldn't for 100 years, and the implications could rewrite science itself. For most people, the term Navier-Stokes equations doesn't sound exciting, but behind that complex name lies one of the most important and most frustrating problems in physics and mathematics. These equations describe how fluids move, from the air flowing over a plane's wing, to the water in your coffee cup, to the plasma swirling around a black hole. They were first written down in the 19th century by Claude-Louis Navier and George Gabriel Stokes. Together, they gave humanity the mathematical foundation to describe motion in fluids, the invisible laws that govern almost everything that flows. But there was one enormous problem. No one could fully solve them. Mathematicians could use approximations, simulations, or special cases, but a complete, rigorous solution, one that worked for every possible condition, remained impossible. So impossible, in fact, that in the year 2000, the Clay Mathematics Institute listed it among the 7 Millennium Prize problems, each worth $1 million for whoever could crack it. It wasn't just about the money. Solving the Navier-Stokes problem meant understanding the very nature of turbulence, one of the greatest mysteries in science. Turbulence isn't just chaos. It's the unpredictable, swirling, ever-changing motion of fluids that appears random but follows precise mathematical laws we could never fully decode. Einstein once said, "When I meet God, I'm going to ask him 2 questions, why relativity and why turbulence?" Then he added, "I really think he'll have an answer to the first." For over a century, this equation mocked the limits of human intelligence, until now. In 2025, a quiet announcement from Google DeepMind sent shockwaves through the scientific world. Their latest AI model, combining graph neural networks, GNNs, with physics-informed neural networks, PINs, had done something extraordinary. It found new, previously unknown solutions to the Navier-Stokes equations. And here's the twist. Those solutions weren't approximations or hallucinations. They were mathematically valid and later verified by human mathematicians from NYU, Brown University, and Stanford. So how did this even happen? DeepMind trained a hybrid AI system that doesn't just learn data, it learns laws of physics. Traditional neural networks, like those that generate images or text, are pattern recognizers. They can't tell if something obeys real-world physical laws. But a physics-informed neural network, or PIN, is different. It's designed so that every prediction it makes has to obey the fundamental equations of physics, things like conservation of energy, mass, and momentum. In other words, it can't just guess an answer. It has to obey the laws of nature. Then, DeepMind went a step further. They merged this with a graph neural network, a type of AI that understands complex relationships between variables. Much like how molecules interact in chemistry, or how parts of a fluid interact in motion. This fusion allowed the AI to simulate billions of fluid interactions across time, learning not just from data, but from mathematical structure itself. After months of simulation, the AI started producing patterns, stable structures in fluid dynamics that had never been seen before. And when mathematicians analyzed these, they realized these weren't random outputs. They were legitimate solutions to parts of the Navier-Stokes equations, solutions that could help explain why turbulence behaves the way it does. To appreciate how big this is, let's break down why the Navier-Stokes equations are considered impossible. At their core, these equations are nonlinear partial differential equations, meaning that small changes in input can cause massive changes in outcome. Think of it like weather prediction. A butterfly flaps its wings in Brazil and a storm hits Texas. That's not a poetic exaggeration. It's a fundamental truth of fluid dynamics. The equations describe how velocity, pressure, and density evolve over time. But once turbulence kicks in, everything starts interacting with everything else. Tiny eddies influence larger vortices, which in turn affect the flow as a whole. The math explodes into near-infinite complexity. Computers can approximate the motion of fluids, but even our most powerful supercomputers can only simulate turbulence up to a certain scale before the equations become unstable. For 150 years, mathematicians wondered, do smooth finite solutions to these equations always exist? Or can the equations blow up, meaning that energy or velocity becomes infinite in finite time? That's the heart of the Millennium problem. And now, DeepMind's AI might have given us a clue. DeepMind's model didn't just guess solutions. It approached the problem as if it were a scientist. First, it was trained on fluid simulations, ranging from laminar, smooth, to turbulent, chaotic flows. Then, the PIN framework forced the AI to respect the mathematical rules underlying the Navier-Stokes system. It wasn't allowed to produce nonsense. Every output had to satisfy the physics. Next, using graph-based reasoning, it mapped out how local patterns in fluid motion relate to global structures, like how a single vortex influences the larger flow field. Over time, the AI began detecting consistent mathematical structures, what researchers call singularities. These are points where physical quantities like velocity become infinite, the exact kind of points mathematicians have struggled to prove even exist. What's more, DeepMind's system discovered multiple classes of singularities, and each of them matched theoretical predictions made decades ago, but never proven. When human mathematicians checked the AI's work, they were astonished. It wasn't making things up. It had independently found valid, verifiable mathematical solutions. The results were later published and peer-reviewed, confirming that the AI's findings hold up under mathematical scrutiny. This isn't just a curiosity, it's a fundamental shift in how science is done. Until now, solving something like Navier-Stokes required either raw human genius or massive computational brute force. Both have limits, but AI operates differently. It doesn't tire. It doesn't assume. It searches every possible corner of the mathematical landscape. This means that AI can now act as a discovery engine, a partner in fundamental science, capable of finding truths we might never stumble upon ourselves. Imagine using similar AI systems to solve other Millennium Prize problems, like the Riemann hypothesis or the Yang-Mills existence problem, or applying it to physics itself, quantum turbulence, black hole accretion disks, or even cosmic fluid dynamics. Already, physicists are exploring whether DeepMind's findings could help us improve weather forecasting by predicting turbulence more precisely. Aerospace engineers believe it could revolutionize aircraft design, optimizing wings and engines for efficiency. And in astrophysics, the same equations describe interstellar gases and accretion flows, meaning this breakthrough could help explain how stars form and how matter behaves around black holes. This isn't just a mathematical triumph, it's the dawn of AI-accelerated discovery. What's remarkable about this achievement isn't just that AI did it, but that humans and AI did it together. The AI uncovered patterns, but it took mathematicians to interpret, verify, and formalize them. This partnership marks a new phase of scientific evolution, one where AI doesn't replace scientists, but empowers them. For centuries, humanity advanced science through tools, telescopes, microscopes, particle accelerators. Now, we have a new kind of tool, one that can reason, hypothesize, and even discover. AI isn't just calculating numbers, it's exploring the unknown. As one DeepMind researcher put it, we're not programming intelligence anymore, we're collaborating with it. With the Navier-Stokes problem finally yielding its secrets, the implications stretch far beyond mathematics. It proves that artificial intelligence can do fundamental science, that it can find truths that eluded human intuition for generations, and that the future of discovery might not come from a lone genius with a chalkboard, but from a partnership between human creativity and machine reasoning. We've entered an era where algorithms can find laws of nature, where neural networks can uncover the universe's hidden patterns, and where science itself is evolving into something new. The mystery that stood unsolved for over 100 years has finally cracked open by AI. And this might just be the beginning. $1 million problem, a century of failure, and a machine that dared to think differently. If AI can solve this, what's next? The origin of consciousness? The laws of reality itself? The age of discovery is back. Powered by intelligence we built ourselves. Thanks for watching. Don't forget to like, share, and subscribe for more deep dives into how AI is reshaping science, technology, and the future of humanity.
Love exploring the world of technology and AI? Don't forget to like, share, and subscribe to NeoTech-Lens for more insightful and exciting content. Hit the bell icon to stay updated with our latest tech and AI innovations. Your support fuels our journey into the future of technology.